Alright, hi everybody. So this is a video for if you missed Monday's class to figure out what type of bond is formed between two atoms. So when we're trying to figure that out, we're really worried about just one thing, and that's electronegativity. Electronegativity is basically the measure of how big of a bully an atom is. So it's how much it wants to, scrounge for atoms or scrounge to take electrons from other atoms. So something with a higher electronegativity really, really wants to steal electrons from other atoms, and something with a low electronegativity does not. So we have three types of bonds: ionic, nonpolar covalent, and polar covalent. Now, ionic bonds are when electrons are not shared, they're just taken from one atom to another. So if something has a much higher electronegativity than something else, meaning one atom wants that electron way, way more, it's not going to share the electrons at all. It's just going to take them. It'll be transferred from one atom to the other, creating a positive ion and a negative ion. The negative ion, called the anion, is the one with the higher electronegativity, because that's the one that was able to take that electron away. So it starts out neutral, it takes an electron from something else, and then it has a negative charge. The positive ion, or the cation, is positive. It has a lower electronegativity, so it loses its electron. It starts out neutral and it loses that electron. Over here, nonpolar covalent bonds, that's when you have electrons that are being shared really, really equally. So you have two atoms that are sharing electrons, but they both want them about the same amount. So you don't have to worry about, which one, like neither one is winning. Think of it like a game of tug of war where neither one is winning. And so those electrons are just bouncing back and forth between them and spending about the same amount of time with each. In the middle here, we have polar covalent bonds. So what that means is that they're still sharing the electrons. It's not like ionic where it was able to just totally take the electron away, but they're not sharing them equally. So one of the atoms wants it more, but not enough to just completely take it away. So in order to figure out what kind of bond we have forming between two atoms, let's think of it like it's on a number line, and this is a number line of difference in electronegativity. So it's when you're comparing the electronegativity of two things and you find the difference by subtracting them. If the electronegativity difference is 1.7 or greater, so it's on this side, it's going to be an ionic bond. That makes sense because if the difference is 1.7 or greater, that's a pretty big difference. That means one of the atoms wants the electrons way, way more than the other one, so it's just going to take it away. They're not going to share at all. If the difference is less than 0.3, or I should say less than or equal to 0.3, it's going to be nonpolar covalent. So a nonpolar covalent bond is when it's shared very equally and the difference is really, really low. So they both want it about the same amount. Now, let's say, for instance, we want to start by looking at a bond between carbon and hydrogen. So in order to do that, we need to figure out what the difference is between the electronegativities of carbon and hydrogen. So I'm going to switch to my periodic table, and this is I'm just getting this from ptable.com like we're used to using in class, and I can click properties up here, and then I can select electronegativity, which I already have selected. So when I select electronegativity on the periodic table itself, you can see the electronegativity. So hydrogen's is 2.2, and I can't draw on it, but it's 2.2. It's in the bottom left there. And you notice it's different on this square where it's highlighted. That's still the atomic mass. But down here, it's 2.2. So that's the electronegativity. So underneath hydrogen, I'm going to write 2.2. And then I'm going to go back to it and find the electronegativity for carbon, which is, I'm going to call it 2.6. We're going to round this. We're going to round these up to the 10th place because that's what we're going to use in class. So carbon is 2.6. So to find the difference, I'm going to subtract. 2.6 minus 2.2 is equal to 0.4. On our number line here, that would fall right about there. So it's pretty weak, but it's in this polar covalent section. So if it's in this middle section, we're going to call it polar covalent. So this bond between carbon and hydrogen is going to be a polar covalent bond. Carbon, because it has a higher electronegativity, it has those electrons more of the time, is going to have a partial negative charge. So that negative electron is spending more time with carbon because carbon has a bigger electronegativity. So it's going to be a little bit more negative. Hydrogen has a lower electronegativity, so those electrons that it's sharing are going to spend more time with carbon than they do with hydrogen, making hydrogen partially positive. And this is going to become important later when we talk about properties of different kinds of compounds. Okay, so now let's look at a bond that forms between two more similarly matched atoms. So let's say Cl2. Oops, that's the wrong pen. Sorry about that. Let's say Cl2. So what Cl2 means is that you have a bond between chlorine and another chlorine. And so I know this is going to seem pretty obvious, but if I look at my periodic table, chlorine's electronegativity is 3.2. So I'm going to go back here, 3.2 and 3.2. And again, I'm subtracting them to find the difference. The difference between 3.2 and 3.2 is 0. And so, because they have a difference of 0, it's going to be way in the nonpolar covalent section. So that's chlorine and chlorine form a nonpolar covalent bond, which makes sense because if you think they're both the same, they both want electrons equally. So when they share it, when this bond is formed of shared electrons, they're going to be bouncing back and forth the same speed between them. Neither one is going to win that game of tug of war. So now let's look at something like sodium, Na. Oh, I should be in green here. Sodium and chlorine. So we just said chlorine's electronegativity is 3.2. And sodium, if we look back at our periodic table, is, let's call it 0.9. It says 0.93, but we're going to say 0.9. And we're going to take the absolute value of this. Another way to think of it is you can just always subtract the bigger one, the smaller one from the bigger one. So you could do 3.2 minus 0.9. But because it's already written this way, I'll just put an absolute value. So whatever the difference is, I'm just going to take the positive, I'm just going to take the positive version of that number. So the difference between 0.9 and 3.2 is 2.3. Hopefully my mental math is right there. And if the difference is 2.3, then it's going to be in the ionic section, right? It's greater than 1.7. And again, this should make sense to you because chlorine has a really high electronegativity. So it really, really, really wants electrons. And sodium has a very low electronegativity. So it doesn't care about taking electrons at all. Since chlorine is going to take that electron from sodium completely, it's going to have a negative charge. Notice there's no partial at this point because they're not sharing. It's not like the electrons bouncing back and forth between them. Chlorine has just become the anion in this situation, so it's got a completely negative charge. Sodium, on the other hand, was neutral and it lost its electron, so it's going to have a positive charge, making it the cation. You really need to know the difference between anions and cations because when we talk about naming, it's going to be really confusing if you don't know the difference there. Another thing you want to notice is that ionic bonds are almost always formed between a metal, in this case sodium, and a nonmetal, in this case chlorine, whereas our covalent bonds, whether it's nonpolar or polar covalent, are usually formed between two nonmetals. So something like chlorine and chlorine or chlorine and hydrogen, something like that where you have two nonmetals together usually forms a covalent bond, whereas a metal and a nonmetal will form an ionic bond. That is about it. So you should be able to fill in that chart and determine the bond types and the charges if you missed class on Monday or if you're just watching this for a refresher. I hope it helped. I'll be posting another video shortly about how to draw Lewis structures and then another one about how to name. Hopefully this helped you guys. See you tomorrow. Bye.